All right, ladies and gentlemen, today we're talking about 7.3, which is scientific notation. This should be a review from you from IM3, and it should go pretty smooth. We're not going to do a whole lot of new information today. In your notes, you need to fill this out. So it says the form C times 10 to the n, where 1 is less than C is less than 10, and n is an integer. An integer meaning it's either a positive or a negative number. So that is what scientific notation is. This part is really important because you always have a number here between 1 and 10, and you always have something times 10 to the power. So an exponent tells us how many places that we're going to move our decimal point. So the negative exponents are going to represent small numbers, and our positive exponents are going to represent very large numbers. So when I'm talking about negative exponents, what I like to say is when I look at something in standard form, do I want this money in my bank account? Well, ultimately, that's $0. Okay, anything less than $1, that is a negative. I do not want that amount in my bank account. I don't want that to be my bank account. However, if I have a larger number, okay, written in standard form, that is a positive. I am positive I do want that in my bank account. So make sure you go ahead and take time to write an example down. And what we're going to do is you're going to see that that is the number. The exponent tells us how many places we move. So on a number line, you've got positive and negative numbers. So a negative number moves to the left. So we're moving to the left 5 places. 1, 2, 3, 4, 5. The new decimal goes here. If we have a positive number, we're moving to the right 5 places. 1, 2, 3, 4, 5. Okay, and that decimal goes at the end. Okay, so we are just converting from standard form to scientific notation. So the first thing I need to do is I need to identify where my decimal is currently at, which is at the very end because there is no decimal. And then where I want to identify where I want it to go. So I want it to be between 1 and 10, so it's always after the first non-zero number. So in this case, it's 1.783. I don't need to write any of the rest of the decimals. What I do need to do is count. So now I've identified where the decimal needs to go. I've written my number. I need to count how many places I have. So remember, it's always times 10, and we start at the end. And I go by threes, so I do 3, 6, 9, 12, 15, and then one more would be 16. Now you can count each one individually. I just think it takes a long time. Okay, so the second number, I look at this and I say, okay, when I first look at this number, I identify that this is not a number I want in my bank account. So I say this has got to be a negative number. It's really, really, really small. I know that my decimal starts here. I know that I want it to end up here. So I'm going to put 6.075 times 10, and then in this case, 1, 2, 3, 4, 5, 6. It's going to be negative 6 because remember, it's a negative number. Here we're going to start at the end. I'm going to do 1.2 because I want it to go in between the 1 and the 2, in between 1 and 10. Move it 3 places, 10 to the third. My decimal needs to go after my first non-zero number, make it between 1 and 10, which would be after my 9. That would be 9.001 times 10, and then how many places am I moving it? 1, 2, 3. So that would be a negative 3 because that is a small number. I do not want it in my bank account. Okay, decimal starts at the end. I need to put it after the first non-zero number, which would be 8. So I have 8.001 times 10, and I would do 3 and 6, 10 to the 6th. Okay, so this one's not technically in scientific notation. However, I want it to be in scientific notation. So I need to I still want my decimal here, so 3.2209. And I'm only counting how many places I'm moving it. So 3.22 is still a larger number than 1, so it's still going to be positive. I just move it 2 places, and then that's all that my answer is. Okay, moving on. Now I have scientific notation, and we're going to move it to standard form. So I used my number line. So we've got my negatives, and then I've got my positives on my number line. So if it's positive, I'm going to move to the right. If it's negative, I'm going to move to the left. So since this is a positive number, I'm going to move my decimal 7 places. I think it's easier just to start up here. 1, 2, 3, 4, 5, 6, 7. So I know that I've got 3 extra places. And then I always double check just to make sure. So if I started here, 1, 2, 3, 4, 5, 6, 7 is at the end. Perfect. I do put in my commas. It's not necessary for you to put in your commas. I do just because I think that it helps me see them. And I'm going to get rid of these little decimal guys in here. It does help me see where I'm at and helps me identify my numbers that I'm working with. Okay, the next one is a negative number. And so since it's a negative number, I'm going to move to the negative point on the number line. And so that would be 5 places. So 1, 2, 3, 4, 5. That means I need 1, 2, 3, 4 extra zeros after my decimal. I like to put a number 0 in front of my decimal. Again, not necessary, but I think it looks nicer and it's more mathematically sound. One thing that you'll find is anytime you're going from scientific notation to standard form and you have a negative number, you're actually going to add 1 less 0 than the number that's written here. Or 1 less. So if I have a negative 7, that means I'm going to do 6 zeros. So I'm going to 0.1, 2, 3, 4, 5, 6 zeros, 4, 0, 1, 2. And I could count it out again. We're going to go 3 places. This one is positive, so we're going to go 3 to the right. I just have to add 1 0 to that one. Okay, so this one's, again, not in scientific notation to start with, but I am only going to move 5 places, and it is positive, so I am going to go to the right. Well, I've got 4 numbers here, so I need to move 1 more, so I just have to put 250. I don't need those numbers in front of it, because since it's just going to be a number that is higher than 1, I just need to put my 250 in. And a negative 1, remember we always just move to the left one, so it would be 1.822. Okay, moving on, next page. So if this is a fill in the blank, we are going to write and we're going to order some scientific notations here. So we're going to write each number in scientific notation first. You're going to order by the powers of 10 and then order the powers. Write the original numbers back in order based on the criteria given. So we've got just a couple more to go through here. And here we go. We're going to start here. And what I want to do is I want to write them all in scientific notation. It gets kind of sloppy if I write them all in standard form. So I'm going to leave this one in scientific notation. This one becomes 9.1 times 10. That would be 3, 4, 5, 10 to the 5th. And this would be 1.32 times 10, let's see, that'd be 3, 6, 7 to the 7th. They're both positive numbers, they're both large. Okay, so I've got 3 numbers I'm working with here. And what I wanted to do is order them by, remember if I go back to my rules, I want to order them first by different powers of 10 and then order the powers. I actually want to look at my numbers first, because that is going to tell me where I'm going to go. So I'm going to look at those orders here. Okay, so I've got a 7 and a 7. Those are going to be larger. We are going least to greatest, so my smaller number is going to be 5. I need to write it back in the original form, which is up here. So 9, 1, 0, 0, 0, 0. Okay, so that's my first one. So I'm looking at my 5 first. That's my smallest number. All right, so now I've got 2 7s. I've got a 7 here and a 7 here. Now I look at the number, okay? So I remember I want least first. So is 5 or 1, my number in front of my decimal, smaller? Well, my 1 is my smaller number, so I have to write it to the original. I'm going to put a little semicolon to separate these out just so I can identify where I'm at. 13,200,000. Okay, and then that means that this is my last one, which is 5.2 times 10 to the 7th, back in its original form. Okay, so I've got 3 more to do here. Remember, I want to put everything in scientific notation first. So this is there, this is there. Oops. This becomes 2.1 times 10 to the 4th. This becomes 1.5625 times 10 to the 4th as well. Okay, so if I want to go least to greatest, my smallest exponent here, let's get this off of here. Okay. My smallest exponent that I have is my 3. So that's going to be my first one. So 4.5 times 10 to the third. Okay, so I like to cross them off so I know that I'm done with that one. All right, so I've got a 4, a 4, and a 4, which means they're all the same. So then I look at my smallest number out front of my decimal. So I've got 15,625 would come next because that was a 1 in the front. I've got 21,000 would come next because that was a 2 in the front. And then that means that finally I've got 3 times 10 to the fourth. Okay? Next one, this is going to be a negative exponent. I'm moving it 4 places, so 6 times 10 to the negative fourth. This one's already written. I'm moving this 3 places, 1.2 times 10 to the negative third. And then this one's already written. Okay, so least to greatest, this one's actually easy because I can just look at the exponents. And just like negative and positive numbers, make sure you follow your negative and positive number rules. So 7.8 times 10 to the negative 6. Negative 6 is my smallest number that I have. Then I've got negative 4, which is 0.0006. Then I've got negative 3, which is 0.0012. And then I've got a positive number. So I've got 2.15 times 10 squared. That one was easy because there wasn't a whole lot to get done there. All right, last one that we have. This one is 1.765. That's actually going to be times 10 to the 0. Remember, anything to the 0 power is 1, so that doesn't change at all. So that is in scientific notation then. This one's already written there. I'm going to move this 2 places, 1.25 times 10, and I move that would be a negative number. I don't want that in my bank account. That would be a negative 2. And finally, 6, oh, that one's already written. Okay, so my smallest exponent, well, I've got a negative 2 and a negative 2, which means which is smaller, 1.3 or 1.2? Well, 1.2 is smaller, so we're going to do 0.0125. That one's done. Then I'm going to do 1.3 times 10 to the negative second. That one's done. I've got a negative 1 or a 0. Negative 1 is smaller. So I've got 6.15 times 10 to the negative first. And finally, 1.765. Okay, we do have some more notes left. It's multiplying and dividing is what we're going to do next. We're actually going to do those in class tomorrow because I think that that'll be another quick review for you, and we will move on from there. Have a great day.